Hello everybody and welcome back to the 2000 Fermat. We're up to question number 17, so how about we have a look at that. So question 17 here. Three circles have centers A, B, and C, with radii 2, 4, and 6 respectively. The circles are tangent to each other as shown. Triangle ABC has, and then we have a couple options. Angle A is obtuse, B is 90 degrees, A is 90 degrees, all the angles are acute, or B and C are equal. Okay. So with lots of different options, they're really asking us to evaluate the triangle and then evaluate each of these claims here. And some of these are going to be easier than others. I'm immediately drawn to E. Angle B and angle C being equal. I think that one would be very easy to show or not show. So let's actually draw our picture and join up our triangles ABC, and knowing these radii, we're going to be able to figure out the side lengths AB, BC, and AC. Okay. So doesn't have to be super exact, but I would say that's actually not that bad. A, B, C. I think that's the order that we had them in. Yeah, A, B, and C. Yeah, and we have, since they're tangent, we can actually connect them up, and the line connecting their centers will pass through the point of tangency. And that means that with a radius of 2 over here, and a radius of 4 up here, and a radius of 6 up here, we see that AB is going to be 2 plus 4, which is 6. And AC is going to be 2 plus 6, which is equal to 8. And BC is going to be 4 plus 6, which is 10. So we can drop the circles now. We don't really need them anymore. We can just look at A, B, and C. A, B, and C. So we have 10 here, we have 8 here, and we have 6 here. Now, if you're like me and you've done a number of these contests, you will hopefully begin to recognize patterns, certain triangles with certain side lengths. 587 is a good one that comes up every once in a while, but ones that really come up are Pythagorean triangles. So 3, 4, 5, 5, 12, 13, to a lesser extent 8, 15, and 17. And one that really comes up a lot is 6, 8, and 10. So this is a Pythagorean triple, which means we're going to have a right angle. And the right angle is always opposite of the hypotenuse, which is the longest length. So A is going to be right angled, and that is one of the options. So if you can see that right away, if you recognize the 6, 8, 10 triangle, you're done this really quickly. Which is why it's always good to know some of these triangles. Some of the really important triangles are the 3, 4, 5. Or knowing the properties of the 30, 60, 90 triangle. That triangle that has interior angles of 30, 60, and 90. That one comes up every once in a while. It's a very important triangle to know. So as I say, if you recognize the Pythagorean triple, you would bubble and see, and you'd move on pretty confident. But let's suppose that you didn't know that. Like I said, some of these are going to be easier. Some of these properties are going to be easier to prove than others. And I'm particularly interested in E. I think that one's very easy to check out. Okay? So if E is true, then this triangle is isosceles, and C and B are equal to each other, and that means that the side lengths opposite should be equal. So if B equals C, then AC is going to be equal to AB, but wait a minute, 8 and 6 are not equal. So our answer is not going to be E. Okay. Let's try and think about the other one. So we know E is out, and so, we can rule some of these out, and then maybe if we're running out of time, we could take a guess. But automatically now, it's going to be a 1 out of 4 guess. So all angles acute and angle A obtuse. These I think are actually a little harder to show. And the first thing that springs to mind with them would be some trigonometry. Now, I don't want to get into trigonometry right now. if I look at B and C, these 90-degree ones, a 90-degree triangle, if I know the side lengths, is very easy to show. So I would focus on B and C next. The isosceles triangle, very apparent. The right angle triangles, I'd have to use the Pythagorean theorem and see if the side lengths confirm that. But suppose that those didn't work out. Well, now I'm down to a 1 out of 2. So I could take a guess, or I could, bow to the pressure and use some trigonometry or some other technique to see if A is obtuse or all the angles are acute. But let's focus on our right angle. So suppose that angle B is 90 degrees. Okay. So if angle B is 90 degrees, we have a right triangle. Then we can apply the Pythagorean theorem or the Pythagorean law. And so that would say, all right, so if B is right angle, then AC is the hypotenuse. So AC squared is equal to AB, or AB squared, plus BC squared. So that means that 8 squared is going to be equal to 6 squared plus 10 squared. So 64 is equal to 36 plus 100, 136, no. Not going to work out. So then I know that the answer is not B. How about C? That's the other 90-degree one. That's the other one that's really nice to check, and then we'd have to make a hard choice. But as I already remarked, angle A. As I already remarked, if you recognize that this is a 6-10 triangle, 6-8-10 triangle, you'll know immediately that angle A is going to be 90 degrees. But let's suppose we didn't. If we assume that, let's check. Is that going to be true? Well, the hypotenuse would then be BC. So BC squared is going to be AB squared plus CA squared. So 10 squared is going to be equal to 6 squared plus 8 squared. So that's 100. It's equal to 36 plus 64. Well, what is 36 plus 64? It's 100. So therefore, turns out that this is right angled, and our answer is C. So we don't even need to bring in any trigonometry, no sines and cosines, nothing like that. We automatically have the correct answer. And its angle A is 90 degrees. So that was very nice. Very good question. There was an easy way if you're a little experienced with these contests, but even if not, there was a way to go about it. Some of these were easier to test, and we progressed through them, and we found the right answer. So, very nice, and in the next video, we're going to look at question number 18. So, I'll see you guys then.